Today we're going to look at how to calculate the slope of a line, primarily if you're given 2 points, but first to look at how to do that from a graph. As a quick reminder, the slope is the rate of change that we've already been working with, and we defined rate of change. We were looking at the rise over run of a line. It tells us the steepness, and it also tells us the direction that the line is moving. And what I mean by that is if the line is rising as it goes across the page from left to right, it has a positive slope and a positive rate of change because slope and rate of change are the same thing. If it's falling as it goes across the graph, it has a negative slope. And then we have two other cases that we're going to talk about towards the end of the notes, and that would be our horizontal line that's neither rising nor falling, and our vertical line that has no sideways movement at all. So we'll look at those again in just a little bit. If it gives me the point 1, 7, and so I go over to 1 and up to 7, I'm going to go by 2's here on my scale just to make this a little bit faster. So if this is 1 and this is the point 1, 7, and then over to 6, 4, so I'm going to label every other one here. So 6, 4. And it wants me to find the slope of the line that would go between those 2 points. Now when they're talking about slope triangles, they're talking about kind of counting this off of a graph. It does not matter which point you start with. So if I start with the point on the left and I want to calculate, remember slope is rise over run. Rise, like if a balloon rises, if an elevator rises, it's going up. So up or down is rise. Run is side to side. So if I'm going from the point on the left to the point on the right and I'm looking at just the rise, that's what it looks like. I'm going in the negative direction because I'm going down. So my rise in this case would be negative. And I moved down 3 units, so it's negative 3. And then I turn the corner and I look at my run. My run is positive because I'm moving towards the positive direction. And in this case, I moved 5 units in the positive direction, so my run is positive 5. So if I'm looking at rise over run, the rise is negative 3, the run is positive 5. Now I said it didn't matter which of those points you started with, and it doesn't. If I started here with the point on the right, my rise would be going in the positive direction, so my rise would have been positive 3, and then I turn the corner for my run. My run, however, would have been in the negative direction because I'm moving towards the negatives, and it would have been negative 5. Well, positive 3 over negative 5 has the same value as negative 3 over positive 5. So it doesn't matter which one is your first point, which some people worry about. They give me this slope formula, but you know what? I'm going to ignore it for a little bit and come back and talk about it in just a little bit. On every problem you do today, I want you to start with m equals rise over run. Because instead of looking at the formula first, I want to look at why that formula makes sense. Most of you remember rise over run for slope. It's been something you've been taught maybe for a couple of years now. There are 3 words in rise over run, and each of those has its own clue. The first one I'm going to look at is over. If it's something over something else, I know I need to set up a fraction bar when I first start to calculate my slope. Then I look at the word rise, and I think on the graph which values rise. Well, y's rise. The y-axis is the vertical axis. It even rhymes. Y's rise. I would highly encourage you to write one of your points above the other point at this time. It's not required, but I encourage you to do it because now you're going to ask yourself which values rise, y's rise. Inside the ordered pair, the x's go before the y's, it's alphabetical order, so the 10 and the 5 are my 2 y values. I know if I'm calculating rise, it has something to do with those 2 y values. And then my run, well, x's run across, so 3 and 1 are my x values. The only thing that really matters here as far as your order, as long as you have your y's over your x's, if I did 10 before 5 in the same direction, the 3 has to go before the 1, because the 10 and the 3 come from one of my points. The 5 and the 1 come from the other point. Now, if I'm stuck and I say, darn it, I forget what goes between those things, we're going to ignore this for just a minute, and we're going to go look at two other numbers. If I had a y value of 2, and it were to rise to a y value of 6, and I asked you how much it rose, you would say 4. Because if it rises from 2 to 6, it rises 4. And my next question to you would be, well, what can you do in your calculator with the numbers 2 and 6 to get an answer of 4? And if you thought about it, you can't add 2 and 6 to get 4. You can't multiply them or divide them. But 6 minus 2 would give you the 4. Which means I'm really trying to find the difference, the change in these two values. I do that by subtracting. That's really what this formula back here says. Rise is your y's, run is your x's, and since I'm finding the change in them, I subtract. The problem with the formula is if you don't understand why the formula works that way, you get to your test, you get nervous, your mind goes blank, because all you did was memorize a formula and you're in trouble. If you can know rise over run, and you can walk yourself through the thought process, you can do this every time. Now, at this point, I'm just going to simplify what's here. 10 minus 5 is 5. 3 minus 1 is 2. In this unit, so it's not always, in the last unit we didn't do this, but in this unit, m is an integer or a reduced fraction. Now, what that means is I do not want you to give me a decimal here, and I do not want you to convert this to a mixed number because I want it to be an integer, or I want you to be able to see the rise over run. This line rise is 5 every time it runs 2. I can't reduce 5 over 2 because the greatest common factor of those two numbers is 1, so I leave it as m equals 5 over 2, and hopefully you circled it better than I did. So the first thing I'm going to write on this second one is m equals rise over run. Well, y's rise, and again, it doesn't matter which point goes above the other point, but I'm going to do this and double check to make sure I copied it correctly. Y's rise, so I'm going to do something with my 8 and my negative 4. Notice I'm not making the negative look like a minus. And then something with my negative 3 and my 5. If I need to walk myself through why this is subtraction one more time, then you could do that. 8 minus a negative 4 is the same thing as 8 plus a positive 4, so that's 12. Negative 3 minus 5 is negative 8. Now in this case, it's still not an integer. If this was 16 over negative 8, I would just say m equals negative 4, because I could take 16 divided by, negative 2. 16 divided by negative 8 and get negative 2. This is not an integer, so I need to reduce it. 12 over negative 8 reduces to negative 3 halves, because 4 goes into both of these. 4 goes into 12 3 times, 4 goes into 8 twice. Now on your calculator, if you punch in 12 divided by negative 8, it's going to give you the decimal negative 1.5. You know on your calculator there's a key that says fraction to decimal above it, F to D. You have to convert it. But that's going to give you negative 1 1/2 instead of the negative 3 halves we're looking for. So above another key somewhere, there's something that looks like a mixed number, probably with an A, B/C. And it has arrows going to something that looks just like a fraction that's not a mixed number. So you may have to, if you get a decimal to begin with, you may have to convert it to a fraction first and then convert it to an improper fraction after that. Now our two special cases are our horizontal line and our vertical line, which means we also have two special slopes. If you think about a horizontal line in terms of rise over run, this line, if I'm picking any 2 points on this line, there is no rise. It doesn't move vertically at all, so my rise is 0. Now my run is some non-zero number. Depending on which direction I'm moving, what this is saying is my run could be positive, or my run could be negative, depending on which is my first point. But I actually do have horizontal movement, so it's not 0. So I'm just going to put some non-zero number in for my run. I could put negative a million, I could put positive 12. I'm just going to say positive 4. Just something that's not 0. Whereas here, on this one, I do, if I'm looking at rise over run, I do have a rise. Again, if I could pick this as my first point, my rise is positive. If I pick the top one as my first point, my rise is negative, but it's not 0. I actually do have some movement between those 2 points in the vertical direction. So in this case, I'm just going to say, well, let's say the vertical movement is 5. Again, it could be negative 5 billion. 5 is just an easy number to work with. The run in this case, though, is 0 because there's no horizontal movement. Now, this seems unrelated, but it's not. In class, I asked you what is 6 divided by 3, and people told me that's 2. And I said, why? Most people said, well, because 2 times 3 is 6, or 3 goes into 6 twice. But really, I'm going to take that 2 times 3, equals 6. So if I take 6 divided by 3 and get 2, I could take 2, multiply it by the 3, and get back to 6 again. So 0 divided by 4 really means what number can I multiply by 4 and get back to an answer, original number of 0? Oh, 0, because 0 times 4 is 0. So the slope of a horizontal line is 0. A vertical line, though, when you see a number like this, it's really saying, what number can I multiply by 0 and get an answer of 5? Well, there's nothing that's going to work. Some people want to say 0, but 0 times 0 isn't 5. Some people will want to say 5, but 5 times 0 is also not 5. There's no number that you could ever tell me that you could multiply by 0 and get an answer of 5. So in this case, for a vertical line, the slope, which is m, is undefined. If you put that 5 divided by 0 in your calculator, it's going to give you one of 3 things. It's going to give you an error. It might just say error, or E. It might say domain error. It might say divide by 0 error. But it won't give you a number for an answer because it can't. So make sure that if you see these special cases, you simplify the calculations. You do the same calculations you see here, but when you simplify them and get something like this, make sure you give this final answer for your slope. Thank you.